Number one in the little quiz here. Truck traveling at 33 meters per second due east comes to a halt by decelerating at 11 meters per second squared. How far does the truck travel in the process of stopping? So when the truck stops, the final velocity is 0. What is the initial velocity? What is the acceleration? Minus 11. There were a few people who did not use negative in there, which caused a great deal of grief for you and me both. So 0 equals 33 squared plus 2 times minus 11d. Solve for d, and you should get 49.5. As I said a little earlier, there are a few people here who need some work on their organization skills. Peyton wants me to line up the equal sign. Great idea. Okay? Your solution should not end up looking like this. Or this. Or this. Or any other combination. Put them in order, please. Important. And label them. That's A. Here's B. What is the velocity of the truck when the truck has traveled 23 meters after beginning to slow down? So we're solving for final velocity. Does that get plugged in?
Yeah.
Okay, thanks. Vf squared equals Vi squared plus 2Ag. So 33 squared plus 2 times minus 11. And now we know the distance is 23. So it's just solving for Vf. 24.1. Right? Pretty straightforward. C asks, is there a C?
Yeah. How many seconds does it take to stop?
Oh, I must have changed the question. It's not on mine here. How many seconds does it take to stop? So you would use, I went with Vf equals Vi plus At. 0 equals 33 plus minus 11 t. T equals 3 seconds. As a group, give me a rating scale 1 to 10 on hardness of that question. It's kind of in that 1 or 2 or maybe 3, only because there's 3 steps. Get the earbud out of your ear. Listen to it. Okay? That one's not that hard. Number 2, suppose a car is traveling at 12 meters per second and the driver sees the traffic light turn red. After 0.51 seconds has elapsed, the reaction time, the driver applied the brakes, and the car decelerates at 6.2. What is the stopping distance of the car as measured from the point when the driver first notices the red light? So there's 2 parts. There's the reaction distance, and then there's the braking distance. And I think you learned that in grade 10 science. V bar equals d over t. When can you use this one? When the velocity is constant. So it's traveling at 12 meters per second. How far does it go in 0.51 seconds, which is the time it takes for your foot to get to the brake pedal? 6.12 meters. That's the reaction distance. And in B, now you're actually doing the braking. Final velocity is 0. The initial velocity is 12 squared. 2 times the deceleration of minus 6.2. Solving for D. D equals 11.6. That is the distance that you travel while your foot is on the brake, which means your total distance, dt, would be adding them together. I would step that up a smidge just because of that 2, yeah, maybe a 3 or a 4. No, I don't even think 5. No, there is no A and B, but there's 2 parts, right? There's 2 braking distances. I think I have time for the last one. That's just, it really wasn't that much. You know what, I probably would make it more on a test, but probably out of 4 maybe. Yeah? Okay. Well, let's go quickly through it. So the police car stopped at, it stooped at a set of lights. No one ever said anything about that. The police car was stooped.
Well, they would have just gotten the ticket.
It was stupid, right?
A speeder goes by at 100. Oh, I guess I should give you mine for converting, right? Okay, so 100 divided by 3.6 is 27.8, I think, when you round it up. Okay, now, the displacement of the police car is VIT plus 1/2 AT squared. The police car starts at 0, accelerates at 3.6 t squared, meaning that the displacement of the police car is 1.8 t squared. The displacement of the speeder, he's traveling at a constant velocity. It's v bar times t. He's traveling at 27.8. His displacement is 27.8 times t. Just like in Jack and the Bus, is this t equal to this t? Same amount of time. Is the displacement of the police car equal to the displacement of the speeder? It is when he catches him. So what do? Well, you set them equal to each other. 1.8 t squared is equal to 27.8 t. In the previous ones, we had one vehicle that had a head start. You'd have like a plus or a minus or something out here, right? This one you don't. So you can just go down to 1.8 t squared minus 27.8 t is equal to 0. And if you choose, you could use the quadratic formula, but what do you remember about factoring? Can I factor out a t? Remember that stuff? Which means that either t is 0 or 1.8, that should be squared. 1.8 t squared.
No.
Oh, you're right, it shouldn't be. I did it right the first time. Either t is 0 or 1.8 t minus 27.8 t is 0, which is when t is equal to 15.4 seconds. And if you stop and you think about it, it makes sense. When are they at the same position? When t is equal to 0. You start the time right there, right? Or 15.4. Clearly that's the hardest part. After that, the rest of it is pretty simple, isn't it? B would just be VIT plus 1/2 AT squared, making sure your initial velocity is 0. The next one is VF equals VI plus AT, making sure your initial velocity is 0. I think you need to spend some time doing some problems this weekend. Take a half an hour or more. I'll pick them up Monday.